Kaya ko rahi, kaya ko whakatiki, no mai rā, koutou katoa. Welcome to you all. Today, we're going to talk to you about digital twins in Aotearoa. We will begin with some broad terms and concepts, what is happening in the New Zealand industry, lessons learned on current projects, and why. Why bother with digital? What is the return on your investment? You'll have us for about 45 minutes. We'll be presenting for about 30 minutes, and we'll be allowing about 15 minutes Q&A at the end of this presentation. Please type your questions in the question box throughout the presentation, and I'll address those during the Q&A. So who are we? I'm going to start with John. John is the property asset manager with over 20 years experience across the local authorities and government agencies. His particular areas of expertise are architecture and design, project management and strategic asset planning. And he was a client for one of the projects that we're presenting today. I'm joined by David Monkman. He is a market leader for buildings performance, leading asset management, asset data for buildings and asset portfolios across WSP. And myself, I'm a technical director for digital engineering in New Zealand. And what that means is my remit covers the digital delivery of all sectors within the WSP New Zealand business. I work directly in strategic projects and also lead our digital advisory business. So let's start with digital. What do these various terms mean? Looking at digital engineering is the process of defining how to work collaboratively, digitally. Building information modeling, or BIM, is object-based digital representations of the physical and often functional characteristics. As-built models, aka LOD 500, is an accurate representation of the built asset as it was installed. And finally, digital twins. Digital twins is a living digital representation of a physical asset that's dynamically updated with data to mimic the true structure, state, and behavior of the physical system which is used to drive outcomes. And noting that this digital twin market is expected to reach $48.2 billion by 2026. But what does this really look like? What does a digital twin really look like? What you're looking at here is flying over my hometown of Wellington. This is a computer-generated digital copy of Wellington. None of this footage is live footage. This is all digital. This is using geometry captured in multiple means, like LiDAR, and they're also using adding textures, lighting, and etc. to present this in a gaming engine technology. And in this context, it's using the platform Unreal. The point of the Unreal gaming engine technology is this is live. This is not a video. This is not a pre-canned path that we're following. You can interact with this live. As you can see here also, it has live IoT sensors and data streams coming from the area, which is also fed up into this user interface. In this context, is allowing you to make informed decisions on multimodal transport options. So what else is happening in Aotearoa right now? What are we up to in New Zealand? There are several digital twin initiatives currently underway in New Zealand. You may have heard of the BIM Acceleration Committee that has been around for a few years. Well, this course, or this group, has largely run its course, and a new committee has been formed called the Committee for Digital Engineering in New Zealand. This is primarily focusing on lobbying the New Zealand government agencies to mandate digital deliverables on all public projects. This is a small group that includes WSP, Canterbury University, Kiwi Rail, smart city councils, downer, NMB. Additionally, WSP are also members of the Digital Twin, it's hard to say, the Digital Twin Challenge and Digital Twin Week. This recently commenced 18-month immersive program has members from leading councils, government agencies, and the private sector. This cohort of digital twin leaders are also working together, authoring blueprints, templates, and knowledge resources on how to implement digital twins. And it's also important to note that this is being provided under a Creative Commons type license. So we're all collectively creating this content that's for all of the community to benefit from. Also watch this space, as WSP will be presenting as part of the Digital Twin Week in the second week of October. Next, we're going to be talking about a couple of New Zealand projects. The first one here, as you can see, is the City Rail Link in Auckland. What you're looking at here, obviously, is an aerial view of Auckland. The blue lines you can see here on the network, this is the existing train network. The orange lines is the City Rail Link. And when completed, it will create a downtown loop. As to date, it stops here at Britomart Station, but this project punches through Britomart Station, creates 2 new stations, and redevelops both Britomart and Mount Eden extensively. This is a $4.5 billion project and approximately 3.5 kilometres of bored and mined underground twin tunnels. A little bit more context on that. So there's an approximate grade change of 70 metres, and it will double the number of Aucklanders within 30 minutes of travel to the CBD. CRL is a game changer for New Zealand. Not only is it the largest and the most complicated transport infrastructure project New Zealand has ever attempted, it is also the first metro and the most onerous mandated digital delivery of any project I've worked on to date. Nothing completed or underway in New Zealand to date has come close to the complexity of this project. What you're looking at here is a one-to-one digital representation of the entire project hosted in the cloud. This comprises of over 400 digital models, over 430 designers from 30 countries and 16 disciplines concurrently contributed to this project. And at its peak during construction, there'll be up to 5,000 workers on the project. There's no limit in the technology these days. The limit is people and process. And as you can see here, this is horizontal, vertical. It's got all the subground infrastructure, and it even has geotech. So how did we do this? So you've probably heard of a term called the CDE, or the Common Data Environment. We like to refer to it as being Connected Data Environments, plural. On the Alliance, it consists of 7+ platforms that traditionally don't talk to each other. So we had to create a hybrid of technologies and operating procedures to create this bespoke connection of platforms. You can see Microsoft SharePoint as the central data repository, and we've connected a variety of other interfaces with that environment. As you can see, there's push-pull from all the different sources. Nothing is used in isolation. Next, I'm going to talk about QTOs, or quantity takeoffs. QTOs have enabled the delivery of accurate, up-to-date quantities to define methods for construction engineers and procurement activities within the supply chain. We've aligned materials and metadata with the BIM models across a project so we can extract this information at any time, at any frequency. Effectively, the quantities are driven from the 3D geometry of the model. This is an automated process and allows us for increased costs and material choice certainty across the project. And this is from the whole life cycle of the project. It's from tender, this is what we tendered, this is what's happening during design, this is what happens during procurement and construction. This is what happens when we change one material typology to another, and what impact does that have on sustainability or carbon net zero initiatives. And again, going back to the common data environment, is because all of these places are connected. Moving on to the classification system. So we developed a robust alliance-specific asset tagging schema. It's used in conjunction with the industry standard Uniclass, and where items weren't available, we created them ourselves within the same principles. And is able to be aligned with the entire client's network. While this image you can see here looks a bit like a cartoon, but is a good representation of what the alliance is achieving. All modeled assets will be able to carry information specific to that piece of infrastructure. The asset ID, the material, the warranty information, location, and discipline, amongst many other fields, are all linked to the geometry. Again, the key message here is all models and data are linked and reused many times over. They're not bespoke, they're not isolated entities, they're structured, connected to various devices, like the tunnel boring machine, and are ready to be used throughout design and construction period and for the remaining life of the assets. The second project I'm going to talk to you today, as you can see here on screen, is the Toi Toi project. We provided a scan to BIM to GIS offering of the Hawke's Bay area and event centre, aka Toi Toi. And John, who'll be presenting next, was a client for this project. This was our workflow. We started with laser scans and drones to record the as-built conditions of this already built facility and create an LOD 500 BIM model. This model was embedded with asset IDs and registers, and we linked these models to live SBM asset data and published to web GIS dashboards. And so what does it look like? This is a resulting BIM model from those scans. It's worth noting we're not just doing LiDAR. Obviously, because we have the scan to BIM model, this is a full construction quality BIM model. So for future works, you've got this editable geometry that would enable that functionality. But with BIM models, BIM geometry or software is quite expensive and it can be quite heavy. So what we managed to do on this project is we ported this across to the ArcGIS platform, and we're able to enable this on that platform so it can be viewed in many devices. And here's an example of that same geometry in the GIS platform. And again, this is not just a visualization, this is a full functional model. Every element in here has asset IDs that connect back to those SBM data sources. Now looking at the GIS portal interface, shown here how we can select rooms, spaces, systems, or individual assets. We can filter further to finishes, quantity, cost, base life, condition grade, etc. We're able to configure this portal any way we want. We can have a private interface, like we just shown, or we can have a public interface or an external facing interface, where the public may want to know the locations of interest, how to get to the venue, or even what is the view like from my seat. Noting again, this is part of the BIM geometry and data has been ported across to this interface. Next, it's my pleasure to hand over the next portion of the presentation to John. Over to you, John.
Thank you, Dan. I think we have had enough pretty pictures and animations. Now down to the real business. In the following presentation, I would like to share some of the knowledge from a client point of view about how engineers and consultants work with the local government asset management sector in the BIM and digital twin adoption in the context of New Zealand. I will use Tui BIM project as an example to demonstrate the decision-making process as for the council as a public asset owner. Local government as an asset owner is different from the private sector in many terms. The key difference is that they have different business objectives set by the organization. See, the private sector, they use asset to use the property asset or building asset to realize the revenue or profit as large as they can. Well, the local government use asset to deliver a service for the current users and the future users as well. In the context of the whole of life cost principle, which is the core concept of asset management. In New Zealand, local government is bound to adopt asset management practice, and that was set in the local government legislation. So they have to prepare and plan for the long term of asset activities. So asset management have a 2080 rules. As some of you may know in this area, that 80% of the overall asset life cost, the whole life cost, has happened in the operation and maintenance state of the life cycle, while only 20% account for the design and the construction. So the current BIM and the digital twin practice in the local government in New Zealand is still new, and adoption rate is low, put it this way. Given the whole industry is still focused on the design and the construction, while the use of BIM in the operational is low. Therefore, there's a huge potential for BIM use in the local government asset management sector. The driving force, there's a driving force, but the multiple layers of driving force behind this project. And we can see from the top is the industry, at the industry level, that we set up the vision to improve the overall efficiency of the construction industry. And as quite common that the construction industry is the least industry to adopt new technologies, far behind others like the car making or the airplane making. The middle level is the sector for the local government, and this is where they set up the strategies to achieve the multiple goals that are set for the organization. And the last level is actually the most beneficial from the BIM adoption. And this is where we start with from the journey. Tui, we choose Tui as our the pilot project for a number of reasons. The building is over 100 years old. It's a historic building with a significant social, architectural, and cultural values to the locals and to the New Zealand nationwide. The Hastings District Council operate as part of the community asset, and we operate 140 different buildings and facilities. And the overall council-owned building and properties with a value of $6 billion New Zealand dollars of replacement value. And we are the leading council in terms of adopting new technologies, and that definitely we are the first one in using BIM for our asset management, in particular the planning part. To do so, we adopt a bottom-up approach rather than the top-down. For those who don't know the difference between top-down and the bottom-up, the bottom-up is also called the grassroots approach. That start from the asset planner, asset manager, or the operational level. While the top-down is come from the senior management, who will decide what and when and how to adopt a new technology like a BIM. Even with the bottom-up approach, we still need a wide support from different parties. We need support from top management. We need support from our the different department, like our IT department and also our GS team. And in addition, the industry supply chain, such as WSP and SPM, and also we need their support as well. As I said, we choose the TUI project for a number of reasons, and this is another key reason, other than the significance of the building, is that we try to create a body double as a backup information for the existing building. By the learning from the lessons of the Notre Dame Cathedral in Paris, and also the Christchurch Cathedral in Christchurch, which is damaged during the earthquakes in 2012. The project outcomes, as described by Daniel in his part of the presentation, which can be summarized in 3 parts. So the one we achieved, and also we created a BIM, as-built BIM model for the building. We established a common data platform using BIM, GIS, and also SPM database. But also we use GIS as our user interface to present the dashboard reporting, but also the communication between the users and the system. Well, we know it's new to us, but also it's new to WSP for the journey. So definitely there's a lot of things to learn from this project. And of course, the key lessons is that it's a process of a trial, fail, and trial again process. And we have identified a number of challenges for now and the future. In particular, the awareness of BIM use is still low in New Zealand, let alone the local government. The second thing is the quantified or justifiable of BIM benefits is still hard to define. And another challenge is that how we're going to work with the existing systems that we need to work out. The last and the most important challenge is that how BIM can be transformed from a tool for the project delivery to BIM to be a service to a tool for service delivery. What's next? So currently we are reviewing TUI project through a peer review process. Based on the outcome of the peer review, And we will carry on to do more BIM projects on our existing building stocks. And eventually, we were going to digitalize all council-owned properties assets. And in a much wider picture, that will help to promote sector-wide BIM and digital twin adoption across New Zealand local governments and other agencies, such as schools and hospitals. Thanks.
Thank you very much, John. Now it's my pleasure to hand over the presentation to David.
Thanks, Dan. The justification for pursuing a digital twin is provided by the potential benefits they can bring. The holistic nature of the digital twins means that benefits are produced across the organisation. In the operations phase of the building life cycle, benefits can relate to managing the facility, operating the facility, and maintaining the infrastructure. We have identified many benefits and consolidated them into a number of examples. To simplify, we've grouped the benefits into some common themes. The first theme is cost and value. Revenue generation, being able to demonstrate the visual look and context of spaces for venue hire and tenancies increases the ability of the owner to generate revenue. Increasing utilisation efficiency. Using the spatial understanding of building occupancy, the building can be filled more efficiently, increasing value to the owner. Cost reduction and recovery. Combining the time dimension with a 3D visualization enables more efficient rostering to better size asset capacity with demand. This allows the optimization of operating hours with energy and soft services costs. The second theme is management, operations and maintenance. Asset management. Building work can be optimized to extract more value from assets, allowing the target extension of renewals and upgrades in relation to known asset usage. Maintenance improvements. Ability to optimize the scheduling of planned and preventive maintenance. For example, carrying out disruptive and noisy work outside hours of space occupancy. Carbon emissions visibility. Ability to understand building carbon emissions in relation to the usage and operating practice of the building. The third theme is planning. Improved operational planning. Logical staging, building maintenance and renewal works so that uptime is maximised and disruption managed effectively. Business continuity planning. Using understanding of spatial context to improve the planning for building threats and hazards. For example, pre-planning for disruption due to fire in a neighbouring building. The fourth theme is risk. Safety improvements. Scenario planning to rapidly analyse the potential impacts of hazards so that evacuation routes can be determined and standoff distances set. Asset uptime and reliability improvements. Identifying and evaluating the impact of single points of failure from multiple perspectives so that critical infrastructure resilience can be increased. The last theme is user experience. Improved user experience. Proactive alignment and right sizing of soft services capacity and levels around the time spaces will be occupied. Minimizing disruption to asset users. Using scenario planning to practice complex maintenance and construction procedures virtually before working on the asset. For example, removal and extraction of large plants whilst the facility is operating. Smart integration. Simplifying the building users' lives by connecting multiple dimensions of their lifestyles to their use of the building. For example, their commute to work, room bookings, courier deliveries, food and exercise. Thank you.
Thank you, David. So what type of investment are we talking about? You've got me for another couple more minutes and we'll get into the Q&A. So how do we enter the digital twin market as such? What are some common entry points to sourcing 3D models? It really depends on if the asset is yet to be designed and built, or does it already exist? Do you need highly detailed and accurate models, or simple volumes and data suffice? The City Rail Link project, for example, is successful due to the project was procured using a shared risk reward alliance contractual model, and that the client demanded full as-built digital models embedded with data. Hence, the entire production team can rely on the digital models and data authored by others, as it was full asset IDs on all elements. It is relatively easy to connect the models with data sources. If we take another look at the Toitoi example, this facility was already built. Existing documentation on the Opera House itself was limited, not in a useful format. So also due to the iconic nature of this facility, the most efficient way to digitize this geometry was the use of laser scanners and drones. This investment made sense for this asset, but not all assets require this degree of fidelity in an editable format. And that's something we're working on with John, is like, what is the appropriate capture technique of various types of buildings? And finally, what we're looking at here is photogrammetry and LiDAR. The first part, as you can see here, is taken about 300 meters in the air using high quality digital cameras, which is then converted to 3D geometry. The second part at eye level is also taken by LiDAR. And this approach is becoming easier and cheaper and largely automated. Noting that last generation of Apple phones and iPads have built-in LiDAR scanners. You can do this yourself. And this is the approach taken by the Wellington City Council digital twins, as shown earlier in the presentation. So digital twins will come in all shapes and sizes with different levels of maturity, scope, and scale. From an asset information model of a single facility to an operation model of an entire transport network with live inputs that can be used for simulations. However, a common distraction with digital twins is the emphasis on visual. Being able to see something can be an efficient communication methodology, but the emphasis needs to be on the structuring of the underlying data. For example, as shown in City Rail Link and Toitoi, they all centered around asset IDs and global unique identifiers in a connected data environment. This environment that had ability to read, write, and interrogate multiple data sources into and from the models. Being able to interrogate and restructure data sources is very important, as different filters or interpretations of the data will be required depending on what stage an asset is in relation to its life cycle. We also need to consider universal access and openness, balance of cybersecurity. We need to consider that digital twins should last for decades, centuries even. Hence, your data frameworks also need to consider new sources of data and technologies as they emerge in formats that can be accessed for decades that are not tied to any particular vendor or version of software. So to reiterate, this is my last slide. Digital twinning is no longer a technological problem, it's a people and process problem. Digital twins let us understand the present and predict the future. The concept is relatively straightforward. You need to determine the purpose of your twin, your why. You need to source your 3D models. You need to define the data structures and sources, and then configure your digital twin platform of choice. Emphasizing this third point, that is the most important and most challenging step, is the configuration of your data structures. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Thank you for your time. We're now going to open it up into Q&A. I see you've got a few questions coming up into the question box already. I'll curate those. So thank you, and please keep on adding some as you go along. All right, first one. Are there examples from of digital twin platforms that are delivering on the benefits of digital twins? Are there any examples of digital twin platforms that are delivering on the benefits of digital twins? Great question, Karen. who's left to answer your question on your behalf. But yeah, all these platforms already are already delivering benefit on the digital twin platform. So as we showed before, the GIS platform that we're using on Toitoi is already giving us additional ways of accessing the data, democratizing the data, visualizing it easily to make informed decisions. Another question here is saying, can you comment on the data standards and naming conventions related to AMDS? I'll throw that one over to you, David.
Thanks, Dan. Well, AMDS is in relation to data standards in relation to transport agency in New Zealand. So we are aligned on digital twins. We're also trying to get alignment in New Zealand with the New Zealand asset management data standards that cover the light and industrial buildings and Three Waters data standards. So the whole thing, as Dan has outlined, is about sharing data between different systems and using a common set of data. So good question.
Thank you. Another question here says, at what stage does BIM become a digital twin? Is it when IoT data is integrated? Great question, we get asked this quite a lot. So the problem with BIMs, digital models, is they often get handed over at the project and they just get digital dust and do nothing. A digital twin is live. It's a live ecosystem. It has a live data connection to the real world environment and stays live for the duration of it as an entity. So when does a BIM become a digital twin? It is when it's connected to data. It doesn't have to be IoT data, but can be multiple sources of data, and there's a live connection staying live for the duration of that facility. What are some examples of live data integrated in the examples from Michael? Yeah, so another example of that is the SVM data is live through to the in the ArcGIS platform. In the City Rail Link example, we would get live data being fed from the tunnel boring machine, for example. Very clear explanations, thank you very much. Awesome, thank you, I appreciate the comment. What digital twin software platforms will be used to operate and maintain City Rail Link? So that platform of choice at the moment is Ecodomus. So we've got the digital models, we've got all the data, we've got all these various ecosystems that are being integrated, and at the handover at the conclusion of the project is going to be an Ecodomus. So there are many platforms out there at the moment. All the vendors are falling over themselves to capture that market. So you need to make a really informed decision or do a bit of research when you're choosing which platform to choose or which one to use. An interesting discussion is, how does this become like a national twin? How do we create a New Zealand national digital twin? Who owns that? How do they play off each other? Next question. How much post-processing is required on photogrammetry LiDAR scan to differentiate 3D elements and assign asset attributes to? Well, that's a really interesting question, actually. I think it's called Black Shark AI or something like that. I'd have to find it out. The short answer is, with AI and machine learning, it's largely automated. You know, the photogrammetry process is becoming easier and easier and easier. So we've been asking this question quite a lot. You know, what is the best way to approach that? When is photogrammetry appropriate? That's a surface captured by photogrammetry versus a full detailed BIM model versus a block. Next question. Are there links to RAM data or potential for use? Yeah, potentially. We've been talking about that. Are you across RAM at all, David?
No, that's not in my area, but I know certainly in relation to road and transport information, it follows the same process as any other information. It's certainly used in some models in relation to traffic modelling and use of things such as mobile cell phone usage for traffic and on a digital twin. So it all links together.
Yeah, we're having that conversation internally quite a lot with our transport department. But yeah, I'll come back to you directly on that one, Ken. Next question, how are we going for time? Here we are. What is the most practical way to upskill in-house facility management teams to use digital twin in lifecycle asset management? Well, that's a great question too. Hey, John, I'll throw this one over to you, mate. You know, how are you working with your in-house teams to engage with this platform? Are you muted, John?
As I said, the BIM and also digital twin, this is still very new, and it's a new in terms, I mean, the industry-wide, and but also in the local government sector is I think is probably still some years away. We do, when we try to recruit our asset managers or project managers, that we see if they have like a background of Revit modeling or any other, the AutoCAD use. That's a start, but to be honest, we still heavily rely on the industry. We rely on our the consultants to support supply the support. Yeah.
Yeah, and the nice thing about those GIS databases or those interfaces that I showed you is that, again, I struggle with that word, but I can't think of a better one. Is democratizes it, right? So it gives it, you don't have to be an SVMS expert, you don't have to be a BIM expert, you don't have to trawl through databases. It presents the information that you need to know and make decisions about that. And so those clients that we're working with those interfaces, I find those very, very engaging. So the upskilling and engagement with that platform is a lot easier than if we're having to go up on the underlying platforms. Next question I see here is, how do you manage change in digital twins? And in particular, how do you allow people to go back and look at older versions of the twin before changes were made? Great question, because the worst place you can keep a digital twin is in BIM software, right? You don't want to create a proprietary software, a proprietary platform that only allows it to be used for 3 versions, and then you're going to have historical problems, permanently long term. So you need to be able to have a way of either upgrading that platform or translating it to a format that isn't tied to that platform. So the way that we're approaching it is we've got the underlying BIM software, we've got it converted into a GIS platform on the toy example, and we're integrating that into a way to engage with that long term. So for example, if they were going to do some CapEx or some changes to part of the facility, we actually have the underlying model which we can use to update and change and reissue. And again, that reframes that question is like, you still have those issues of maintaining that model. So do you have people internally in-house that can do that? If you don't, that's okay, because you can provide that model to the industry in a common format that most of the industry use. Next question, is there a link between actual operations and the model? For example, if a train gets stuck, derailed to workshop for a fix. Thank you, Ken. Well, in the City Rail example, I don't have any trains in there yet. They've still got the tunnel boring machine digging a hole. So hopefully that doesn't get stuck, which apparently can get stuck if they don't keep moving. So I can't really answer that question in this context, but yes, there is plenty of examples of that globally. Are you investigating real-time gaming engines? Oh, just moved. Real-time gaming engines to visualize your models. It now seems feasible to have both technically accurate models and high visual qualities. Completely agree. It's all about the gaming engines now, and Unreal seems to be the platform of choice. So those, you're not just talking about buildings, you're talking about cities and worlds. And note we're at time. I've spoken to my colleagues and we're able to keep talking for another 5 minutes or so. So I'll keep going through those questions. If you feel like you need to drop off, please do so. Otherwise, I'll get through the rest of the questions for the next 5 minutes or so, and then we'll call it. That was a great presentation, team. Thank you. Can you give us an indication of the costs? Good question. But the costs, obviously there's some commercials around that. So the cost of doing a full scan to BIM to GIS platform is substantially more expensive than photogrammetry. Because photogrammetry, you're just blasting around with a camera or a LiDAR and converting it to a relatively accurate mesh. Where with what we did on that example was a one-to-one as-built example of the entire facility. So it's about return on investment on the complexity of the platform. You wouldn't do a full scan to BIM of a toilet block, for example, but you still need some information around that. So maybe it's just a volume or a rectangle with some data is appropriate in that context. Where with the toy example, that justified the additional expense. Can you speak of the security of the data with respect to preventing it from becoming an evil actors guided to target acquisition? Mark, great question. Of course, it had come from you, Mark. But yeah, cybersecurity is a really hot topic at the moment. Obviously, there's some concerns around that. We've done work with the Defence Force in the past, and they're very, very sensitive around that. So yeah, cybersecurity is a very hot topic. But the way that we do control that is data sovereignty. Where does the data live? How do you access it? Who can access it? What's made available publicly? What's made available internally? There's many, many ways that you control that. But that is a very serious consideration for everyone when you're implementing digital twins, is the security of the data that you're creating. I had a couple more questions that come through. Is digital twin only for built asset and construction? No, it's for any stage of the life cycle of the project. Where you can use it throughout design, pre-planning, right through to disposal. I'd like to know if and how public engagement can be integrated into the decision-making process through the digital twin. Another great question. We've had that before, like when we're doing a new proposal, and you can see those near maps examples, we can drop it in the comment. You can imagine the increased information fidelity if you're able to provide that in a three-dimensional context that you can engage with, and the next step even better when you do scenario planning. Another question's just come through. Is there a New Zealand National Digital Twin Framework document for the public with technical details? WSP is a major global company. What is its view on such a document? Thank you, Roy. So the question, that's what CodeENS is for, that Committee for Digital Engineering in New Zealand. That is what that remit is. That remit is to go to the national government, create those frameworks and mandate it. And you also have the Digital Twin Week and the Digital Twin Challenge. The intention of those, the Digital Twin Challenge in particular, in about 18 months' time, a lot of that material will be provided, and also via like those committees within New Zealand. A couple more questions. What is the role of digital twins, maybe a national one, as part of the RM reforms? Did you comment on that, David? We talked about that one before, didn't we? The RM reforms? No, we didn't actually. You didn't have a comment on that one. That was I don't have a position on that one. I'm not. I don't have a lot to comment on that one. Sorry. I'll have to come back to that question. I'll return to that one. How scalable up or down is the technology for infrastructure planning? It's infinitely scalable, to be honest. Like with the gaming engine technology, they talk about worlds, not just buildings and cities, but entire worlds. This technology now is to the point where there's no limit on what you can do. Great. Well, I think that's got to all of our questions. We're 5 minutes over. Thank you very much, David and John, for co-presenting with me. I really enjoyed speaking with you. You see all our contact details on the screen now, so please do not hesitate to reach out to any of us if you'd like to dive into it a bit deeper. Thank you very much for your time. I'm now ending the session.
Thank you.